Welcome back to Sleepy Orbits. Wherever the night has put you, under the covers with the lights out, or lying there listening to the house settle, you're in the right place. Tonight, we need to talk about something that has already happened. Almost everything you can see in the night sky, almost every galaxy ever photographed, almost every point of light in every deep space image you have ever admired is already gone. Not dying, not fading, gone in the strictest sense physics allows. About 94% of the universe we can see has already passed beyond our reach, forever. If we launched a message tonight at the speed of light and let it fly for eternity, it could never catch more than a few percent of the galaxies in our sky. You've probably heard that the universe is expanding. That sounds slow and distant and harmless. But here's the thing most people don't realize. The expansion is accelerating. And that acceleration draws a line through the universe, a one-way line. Every second, thousands of stars slip silently across it, out of our future, permanently, and the sky never looks any different. The universe is quietly saying goodbye, one galaxy at a time, and tonight, you're going to learn how we found out. By the end of tonight, the darkness above your roof won't feel emptier. It will feel like the most precious view anyone will ever have. One thing before we begin. If you fall asleep partway through, good. That's the point. In the morning, tell me in the comments the last thing you remember hearing, and if you make it to the end, tell me which part of the universe's long goodbye stayed with you, and what you'd like us to explore next. If these nights help you rest, a like or a subscribe helps this channel more than you'd realize. Now, let's begin. Start with a picture you've seen before. In 1995, astronomers pointed the Hubble Space Telescope at one of the emptiest patches of sky they could find, a speck of blackness near the Big Dipper about the size of a grain of sand held at arm's length, and they simply let it stare. For 10 days, the telescope collected whatever light happened to arrive. Most astronomers expected nothing. What came back was one of the most famous images in the history of science, the Hubble Deep Field. 3,000 galaxies in a patch of nothing, spirals, ellipticals, smudges of blue and gold, each one a city of billions of suns, crowded into a keyhole view of the dark. Everyone has seen that photograph. Almost no one has been told the truth about it. It's not a window, it's an album. Most of the galaxies in that image are not places we are looking at. They are places we are remembering. Their light left them billions of years ago, and in the time it spent crossing the dark, the expansion of the universe carried them so far away and is now carrying them away so quickly that nothing we do ever for the rest of time can reach them. Not a signal, not a ship, not a message moving at the fastest speed reality permits. If one of those galaxies is home to someone wondering, tonight, whether anyone else exists, we can never answer. We can only be for each other a photograph. Hold your hand up toward the ceiling. However wide the sky above your house is tonight, statistically, nearly all of it, 19 galaxies out of every 20, is in that condition. Still visible, already unreachable. The light keeps arriving, faithful as mail from a town that no longer exists, and it will keep arriving for billions of years. But the senders have left our future. What remains is the greatest going-away collection ever assembled, printed across the entire sky, updated nightly, and mistaken by every generation for a map of places we might one day go. And the line keeps moving. By some estimates, roughly 20,000 stars cross it every second. Every second, another 20,000 suns whose light will one day arrive here for the last time. It is happening now while you're lying there. It will happen all night and all day tomorrow, and it will never, ever pause. Here is the strangest part, the part that will carry us through the whole of tonight. Nothing up there looks different. No star blinks out, no galaxy vanishes while you watch. The goodbye is completely, perfectly invisible, which raises the question this entire video exists to answer slowly and gently until it makes sense somewhere deep in your half-asleep mind. How can something be right there in the sky and already gone? To answer that, we need to start with the discovery that broke astronomy's heart twice. Once in 1929, when we learned the universe was running, and once in 1998, when we learned it was running away. For almost all of human history, the universe was furniture. The stars were fixed. That was practically their job title. Ancient astronomers called the outermost layer of the heavens the sphere of fixed stars, and for thousands of years, nothing anyone observed ever contradicted it. The patterns your grandparents saw are the patterns you see. The sky, whatever else it was permanent. The first crack in that permanence appeared quietly in the 1910s at an observatory in Flagstaff, Arizona. An astronomer named Vesto Slipher was doing something painstaking and new, spreading the faint light of the spiral nebulae, those little whirlpool smudges scattered through the sky, whose nature nobody yet knew, into spectra, the rainbow fingerprints of their light. Reading a spectrum tells you what something is made of, but it tells you something else, too. If the source is moving toward you, its light arrives slightly compressed, shifted toward blue. If it's moving away, the light arrives stretched, shifted toward red. It's the same physics that bends the pitch of a passing siren, and it turns every spectrum into a speedometer. Slipher expected the little whirlpools to be drifting gently, some approaching, some receding, the way things drift in any calm crowd. Instead, nearly every spiral he measured was rushing away, not drifting, rushing, at hundreds of kilometers per second, faster than almost anything then known. And the pattern was lopsided in a way that made no sense. Almost none were approaching. It was as if he had opened the curtains one morning and found every car on the street driving away from his house. Nobody knew what to make of it, partly because nobody yet knew what the spirals were. That question was contentious enough that in 1920, the National Academy of Sciences in Washington staged what astronomy still calls the Great Debate. Two eminent astronomers, Harlow Shapley and Heber Curtis, arguing publicly over the scale of everything. Shapley held that the Milky Way was the whole universe, the spirals mere whirls of gas inside it. Curtis held that the spirals were island universes, entire other galaxies, impossibly remote. Both men argued well from the evidence available, which is a detail worth filing away for much later tonight. When the evidence is insufficient, even the careful can be wholly wrong about the size of reality. The debate couldn't be settled by rhetoric. It was settled within a few years by a measuring tape, one built by one of the quietest heroes in the history of astronomy, Henrietta Swan Leavitt. Leavitt worked at Harvard as a computer, the job title given to the women employed at low pay and lower recognition to measure photographic plates. Her assignment was a catalogue of variable stars, stars that brighten and dim in repeating cycles, and in a particular family of them, the Cepheid variables, she noticed something nobody had ever seen. The slower a Cepheid's cycle, the more luminous the star truly was. The rhythm revealed the wattage, and that changes everything. Because if you know a star's true brightness and you can see how faint it appears, you can calculate how far away it must be. Leavitt had found the universe's measuring tape, a way to read distance directly from starlight. In 1923, Edwin Hubble, working with the largest telescope on Earth at Mount Wilson in California, found a Cepheid flickering inside the Great Spiral in Andromeda. He ran Leavitt's mathematics. The answer placed Andromeda roughly 1 million light-years away, far outside any possible boundary of the Milky Way. The modern figure is 2.5 million. The first measurement was rough, but the verdict was right. The whirlpools were not clouds. They were galaxies, other Milky Ways, and the universe was suddenly catastrophically larger than anyone had believed. Now Slipher's fleeing spirals took on a new and stranger meaning. Entire galaxies were rushing away from us. And when Hubble combined the distances with the speeds in 1929, the pattern that emerged was the single most consequential graph of the 20th century. The farther away a galaxy is, the faster it recedes. Double the distance, double the speed. Everything, everywhere, moving away from everything else in exact proportion to separation. Take a breath with that, because it's easy to hear it wrong, and hearing it right is the key to the entire night. The galaxies are not flying away from us through space, like shrapnel from an explosion with the Milky Way at the center. If they were, we'd have to be sitting at the exact middle of the universe, which would be suspicious, to say the least. The truth is stranger and more democratic. Space itself is stretching. The galaxies are more or less standing still, each in its own neighborhood, and the distances between the neighborhoods are growing because new space is quietly appearing between them. The classic picture is a loaf of raisin bread rising in the oven. The raisins don't swim through the dough swells, and every raisin watches every other raisin drift away. And here is the crucial detail. Each raisin sees the same thing. From any raisin you choose, all the others recede, and the far ones recede fastest because there is more swelling dough between. No raisin is the center. Every raisin feels like the center. That's Hubble's law, seen from the inside. The galaxies rush away from us not because we're special, but because that is what living in stretching space looks like from every address in it. The Big Bang, it follows, was not an explosion at a point in space, with debris flying outward into the dark. It was the beginning of the stretching, and it happened everywhere at once. The place where the Big Bang occurred is here. It's also the Andromeda Galaxy, and the farthest smudge in the deep field, and the space inside your bedroom. Every point in the universe is a point the beginning happened at, carried apart from all the others ever since. And the redshift, that stretching of light toward the red that Slipher first measured, turns out to be something more beautiful than a speedometer. The light isn't shifted because the galaxy was speeding when it sent it. The light is stretched because the space it traveled through stretched while it was in transit. A photon leaves a distant galaxy as crisp blue light. It flies for billions of years, and the road lengthens under it as it runs, pulling its wavelength longer and longer, so that it arrives red or infrared, or, from the earliest, farthest sources, stretched into microwaves. Every ancient photon is a piece of elastic that has been quietly recording the growth of the universe for its entire journey. When astronomers measure a redshift, they are reading the universe's growth rings. There's a painful irony buried in this chapter of history, and it involves the most famous scientist who ever lived. A decade before Hubble's graph, Albert Einstein had completed general relativity, and when he applied his own equations to the universe as a whole, they told him something he refused to believe. The universe could not sit still. The mathematics insisted that space filled with matter must be either expanding or contracting. A static universe was like a pencil balanced on its point. Einstein, sharing every generation's certainty that the heavens were permanent, added a term to his equations to hold the universe still. A repulsive pressure built into space itself, tuned precisely to cancel gravity's pull. He called it the cosmological constant, and by his own later account he came to regard it as his greatest blunder, because if he had trusted his equations, he could have predicted the expansion of the universe a decade before it was observed. Others did trust them. A Russian mathematician, Alexander Friedman, worked out the expanding solutions in the early 20s and died young, barely heard. And a Belgian physicist, who was also a Catholic priest, named Georges Lemaitre, independently derived the expansion, connected it to the galaxy redshifts before Hubble's paper, and then pushed the logic to its stunning conclusion. An expanding universe, run backward, converges, smaller, hotter, denser, back to a beginning he called the primeval atom, the seed of what we now call the Big Bang. A priest with equations, politely informing Einstein that the universe had a birthday. Einstein at first told Lemaitre his mathematics was fine, but his physics was abominable. The universe in due course, sided with the priest. Hold on to Einstein's discarded constant, by the way. Tonight is a long story, and that particular piece of crumpled paper, a repulsive energy built into space itself, thrown away in embarrassment, gets uncrumpled near the end of the century in the most spectacular reversal in the history of physics. So the universe stretches, and has been stretching for around 13.8 billion years. On its own, that's wondrous, but not alarming. A stretching universe could be a slowing universe. Gravity, after all, pulls. Every galaxy tugs on every other. The expansion should be coasting against that collective drag, easing off the way a ball thrown upward eases as the Earth pulls it back. For most of a century, that was precisely the expectation. The only question astronomers thought they were asking was, how quickly is the expansion slowing? Enough to someday stop and collapse back? A big crunch? Or not quite enough, so that the universe coasts outward forever, gently decelerating into the dark, slowing to a stop, or slowing forever? Those were the choices. Both teams that set out in the 1990s to measure it would have told you the same thing. They were measuring the universe's deceleration. The universe had other plans. To measure whether the expansion is slowing, you need to compare the universe's stretching speed now with its stretching speed long ago. And the only way to look long ago is to look far away, which means you need to measure enormous distances precisely. Cepheid stars, Leavitt's measuring tape, fade from view beyond nearby galaxies. For the deep universe, you need a brighter candle. You need a dying star, a very particular kind. Scattered through every galaxy are white dwarfs, the dense, Earth-sized embers left behind when stars like our Sun finish their lives. A white dwarf on its own is stable, cooling quietly for eternity. But a white dwarf with a close companion star can steal material from it, growing gram by gram. And there is a hard limit to how massive a white dwarf can be. The limit is about 1.4 times the mass of the Sun, and it is set by fundamental physics, the same everywhere in the universe. When a white dwarf crosses it, the star detonates completely, catastrophically, in what astronomers call a Type 1a supernova. Because the fuse is always the same length, the explosion is always essentially the same brightness. For a few weeks, one detonating white dwarf shines about 5 billion times brighter than the Sun, briefly outshining its entire galaxy. Same true brightness every time, everywhere. Which means these explosions are lighthouses of known wattage. See one, measure how faint it appears, and you know how far its galaxy is, even billions of light years away. The universe, it turns out, comes equipped with standard candles powerful enough to survey its whole depth. You just have to catch them, because each one is a few weeks of light in a random galaxy, unannounced. In the 1990s, two rival teams set out to catch them by the dozen. One, the Supernova Cosmology Project, led by Saul Perlmutter in Berkeley. The other, the High-Z supernova search team founded by Brian Schmidt, with a young astronomer named Adam Rees leading the crucial analysis. The rivalry was real, two groups, same prize, racing to measure how much the universe's expansion had slowed since the light of those distant detonations set out. The method was simple to state and brutal to execute. Photograph wide fields of galaxies, photograph them again weeks later, subtract, hunt the differences for new points of light, follow each candidate with the world's biggest telescopes before it fades. Do this for years. Assemble dozens of standard candles stretching billions of light years deep, a chain of lighthouses reaching most of the way back through cosmic history. Then compare, given each supernova's redshift, how much the universe stretched while its light was in transit. How bright should it appear if the expansion has been gently slowing? In 1998, both teams arrived independently at the same impossible answer. The distant supernovae were too faint. Not much. A whisper, a few tenths of a magnitude, but consistently across explosion after explosion. Too faint means too far. Too far means the universe had stretched more than any slowing universe allows. The expansion of the universe is not slowing down. It is speeding up. It's hard to overstate how unwelcome that answer was, including to the people who found it. Adam Rees later described checking the analysis over and over, assuming an error. Brian Schmidt described his reaction as somewhere between amazement and horror. A universe that decelerates makes sense. Gravity pulls, motion coasts against it. A universe that accelerates needs something pushing, something built into space itself, growing stronger, in effect, as space grows larger. An energy in the vacuum, in the nothing, actively pressing the cosmos apart. When both rival teams, competitors with every incentive to catch each other's mistakes, published the same conclusion within months of each other, the field had no choice but to take it seriously. Science magazine named it the breakthrough of the year for 1998. 13 years later, Perlmutter, Schmidt, and Rees shared the Nobel Prize in Physics. And here is the reversal I asked you to hold on to. The best simple description of this push, the mathematical form that fits the data most naturally, turned out to be sitting in the literature already, 80 years old, with Einstein's fingerprints on it. The cosmological constant. The term he invented to hold the universe still, then threw away as his greatest blunder, uncrumpled and repurposed, not tuned to freeze the cosmos, but present at just the strength to fling it open. Einstein was wrong that the universe was static, and wrong again, in a sense, to be embarrassed. The piece he discarded appears to be the single largest component of reality. Physics keeps no wastebasket. It keeps drafts. The push needed a modern name. A colorful cosmologist named Michael Turner gave it one: dark energy. The name is honest about our ignorance. It is dark in the sense of unknown. But its portion of the universe is not small, and this is worth saying slowly, because it never stops being astonishing. When you total up everything that exists, all the matter of every kind, every star, every planet, every cloud of gas, every galaxy, plus all the invisible dark matter holding those galaxies together, you have accounted for less than a third of the universe. Roughly 68% of everything, the single largest ingredient of reality, is this: the push, the thing in the vacuum, the reason the expansion accelerates. We named it, measured its strength to a few decimal places, built it into our best model of the cosmos, and we do not know what it is. And with acceleration, the future of the universe quietly turned inside out. In the old coasting universe, patience could cross any distance. Light launched tonight would eventually reach any galaxy you named. The gaps grow, but ever more slowly. Given enough eternity, every journey completes. In an accelerating universe, that promise is revoked. The gaps between distant galaxies don't just grow, they grow faster every year. Out beyond a certain distance, the stretch of the road outruns anything traveling along it, including light itself, which means the accelerating universe comes equipped with something the coasting universe never had. An edge, not of space, but of possibility. A distance beyond which someday stops existing. Astronomers call it the cosmic event horizon, and it is the reason most of the universe is already gone. But before we walk out to that edge, there's a question hiding in the 1998 result that deserves its own chapter, because its answer contains the most bittersweet fact of the entire night. If gravity pulls and dark energy pushes, who was winning before? Has the universe always been accelerating? Or did something change? Something changed, and we know almost exactly when. Think about what happens to the two rivals as the universe grows. Matter dilutes. All of it. Stars, gas, dark matter alike. The amount of stuff is fixed, and the space holding it keeps stretching. So every era of expansion spreads the same matter through a larger volume. The early universe was crowded. The present universe is sparse. The future universe is sparser still. Gravity's team thins with every passing eon. Dark energy does not dilute. That is its single most important property, and the strangest. It behaves as a feature of space itself. So much push per cubic meter, the same in every cubic meter. No matter how many cubic meters there are, stretch the universe and you don't spread dark energy thinner. You make more of it because you've made more space. Gravity's team thins. Dark energy's team grows with the arena. Run that contest from the beginning, and the story of the universe splits cleanly into two acts. In the young, dense cosmos, matter dominated utterly. Gravity's pull outweighed the vacuum's whisper of push, and the expansion flung outward by the Big Bang was slowing down, exactly as everyone's intuition said it should. That was the state of play for roughly the first 8 to 9 billion years, a decelerating universe coasting against gravity's drag, its expansion easing century by century. Then, somewhere around 5 to 6 billion years ago, right around the era, as it happens when the Sun and the Earth were forming, the thinning crossed the line. Matter's dilution finally dropped gravity's team below the vacuum's steady push. The brake let go, the accelerator engaged. Cosmologists, who are rarely accused of poetry, gave the moment of transition a name that sounds like it escaped from a 1950s dance craze: the cosmic jerk. Jerk being honestly the technical term for a change in acceleration. The universe decelerated for 8 billion years, hit the turnover, and has been speeding up ever since. We live in Act 2. And here's the thing, we've seen the turnover. This isn't inference stacked on theory. In the years after 1998, skeptics quite reasonably offered tamer explanations for the two faint supernovae. Maybe intergalactic space held some thin grey dust, dimming distant explosions and mimicking acceleration. Maybe ancient supernovae simply detonated a little differently. There was a clean way to settle it, look even deeper. If dust or odd physics were the cause, supernovae should just keep getting anomalously fainter with distance. But if the universe truly turned over, if Act 1 was deceleration, then the very deepest supernovae, exploding back in the matter-dominated era, should flip the pattern and appear slightly brighter than a coasting universe predicts. In 2004, Adam Ries and colleagues, using the Hubble telescope to net supernovae from more than 9 billion years ago, found exactly that flip. The deepest candles were brighter, the nearer ones fainter, and the crossover sat just where the two-act story demanded. Dust can't do that. Only a universe that braked first and accelerated after can. The skeptics' alternatives died in that dataset, and the two-act history, deceleration, turnover, acceleration, moved from bold claim to measured fact. Now come back to tonight's subject, reachability, and feel what the two acts mean for it. Because this is the bittersweet part. During Act 1, the decelerating age, the universe was becoming more connected. A slowing expansion is the ant's best friend. Every year the stretching eased, more of the cosmos fell within reach of a photon launched fresh. Regions once receding hopelessly fast slowed into contact range. The sphere of the possible grew, era after era, for 8 billion years. The universe in its youth was in the business of introducing its parts to one another. Had that continued forever, patience really would have conquered everything. Every galaxy eventually reachable, every message eventually deliverable. The whole cosmos one gradually unifying household. The turnover ended all of that. The moment acceleration began, the sphere of the possible stopped growing and began, in the ways that matter, to close. The reachable fraction of the universe peaked. There was a literal high water mark, an era when the universe was the most connected it would ever be. And everything since has been the tide going out. We are not living at the high water mark. We missed it by billions of years, but we are living in the long golden afternoon just after it, close enough that the water is still high, that 19 in 20 lost is a tragedy rather than a rounding of everything to zero. that the sky still holds the full album. The Milcomedans get the drained shore. We got the afternoon. And there is one more twist of timing, almost too neat to say out loud. The turnover happened roughly when our solar system formed. The Earth condensed, life kindled, and everything you love unfolded entirely inside Act 2, the leaving age. Humanity has never existed in a universe that was coming together. We are, and have always been, creatures of the long goodbye, born after the party peaked, in time to see the guests still filling the rooms and just barely beginning to reach for their coats, which is exactly why we owe the horizon a careful look. Time to walk out to the edge of the possible and to meet the strange rule that lets most of the universe outrun light itself without breaking a single law of physics. Before the horizon can make sense, we have to walk carefully past the objection everyone rightly raises: nothing can travel faster than light. That rule is real. Einstein's speed limit has passed every test a century of physics could throw at it, and yet astronomers will tell you in the same calm breath that most galaxies in the observable universe are receding from us faster than light, right now, tonight. Both statements are true. The reconciliation is the single most important idea of the night, so let's take it slowly. Einstein's limit applies to things moving through space. Nothing overtakes a beam of light in a race. No rocket, no particle, no signal. That law is never violated anywhere by anything we're about to discuss. But the expansion of the universe is not motion through space. It is space itself stretching, and there is no speed limit on that. The rulebook governs runners on the track. It says nothing about the track itself growing longer. Remember Hubble's law: every stretch of space expands in proportion to its length. The numbers are almost comically gentle. A stretch of space 1 million light-years long grows by only about 20 kilometers per second. Bicycle race speed spread across a distance light takes 1 million years to cross. Space is barely stretching at all, locally. But the stretching adds up with distance, and the universe has a lot of distance. 10 million light-years of road stretch 10 times faster than 1. 1 billion light-years stretch 1,000 times faster. And somewhere around 14.5 billion light-years out, the arithmetic crosses a memorable threshold. The road between us and there is growing by more than 300,000 kilometers every second. Faster than light, not because anything out there is moving. The galaxies at that distance are as stationary in their own neighborhoods as we are in ours, orbiting their clusters, minding their business. The ground between us simply grows faster than light can run. So picture the loneliest runner in the universe, a photon launched toward us tonight from a galaxy out beyond that line. It travels at exactly the speed of light forever. It can do nothing else, but it's running on a treadmill whose belt accelerates always in the wrong direction. For every kilometer the photon closes, the road under it adds more than a kilometer. It never stops, never slows, never turns around, and it never gets here. It recedes from us at full sprint, running toward us, carried away forever. That, precisely, is what unreachable means tonight. Not far, not slow to arrive, never, with the never enforced by geometry, patiently, without malice, against the fastest thing that exists. Now, a careful mind, and yours may be pleasantly drowsy, but I know it's careful, will spot a subtlety here. If light from beyond that faster-than-light line can never reach us, how are we seeing galaxies out there at all? Didn't we say the observable universe extends 46 billion light-years far past it? The answer is lovely. The light we're receiving now is old. It set out billions of years ago, when those galaxies were much closer, close enough to be on our side of the arithmetic. The photons arriving tonight from the deep field crossed most of the gap before the gap grew hopeless, like letters posted before a town got snowed in. Seeing a galaxy tonight tells you the mail was getting through long ago. It tells you nothing about whether a letter posted there tonight can ever arrive. There's a classic puzzle mathematicians use to train intuition for exactly this, and it makes a fine thing to fall asleep on. Imagine an ant walking along a rubber band 1 meter long, and every second the whole band stretches by another meter. The ant walks 1 centimeter per second. The band grows 100 times faster than the ant walks. Surely the ant never reaches the end. And yet, if the stretching is steady, it does. Because the stretching helps the ant too. The portion of band behind the ant stretches along with the rest, carrying the ant forward like a current. The fraction of the band the ant has covered never shrinks and creeps ever so slowly toward complete. Given absurd amounts of time, the ant arrives. That is a photon in a universe that expands steadily. Patient light eventually wins against any steady stretching, no matter how fast. In the coasting universe astronomers believed in before 1998, that was the promise. Every ant arrives, every photon lands, eventually, always. Acceleration breaks the ant. When the stretching itself speeds up, each second adding more band than the second before, the current helping the ant along can no longer keep pace with the road piling up ahead. The covered fraction stalls, and beyond a certain starting distance, it never approaches the end at all. That's the whole difference between the old universe and ours in one rubber band. Steady stretching is a long road. Accelerating stretching is a closed one. 1998 didn't just change a graph. It took away the ant's guarantee. One more strangeness, while we're being precise, and this one delights me. Receding faster than light is not some rare condition of the outermost fringe. Run Hubble's law across the sky and it turns out most galaxies we routinely observe are receding faster than light right now. Every galaxy whose light is stretched beyond roughly 2.5-fold sits past that line, and deep surveys are full of them. Superluminal recession isn't the exotic case. It's the ordinary condition of the universe at large. The genuinely local, slower-than-light cosmos, The part that behaves the way intuition expects is the thin bubble immediately around us. That question, can a photon leaving now ever reach us, has its own line in the sky, and this is the line the whole night turns on. Sit with the difference for a moment, because it separates two things that sound identical. There is the edge of what we can see, the observable universe. That's set by the past, how much time light has had and how much closer everything used to be. It reaches out about 46.5 billion light years, and it grows a little every day as older, farther light finally straggles in. And there is the edge of what can still happen to us, the cosmic event horizon. That's set by the future. From how far away can a photon launch today, given infinite time on an accelerating treadmill, still complete the journey? Run the numbers for our universe and the answer comes back at roughly 16 to 17 billion light years. 16 or 17 against a visible universe of 46.5. The window of the possible is a small circle drawn inside the window of the visible. Everything in between, every galaxy in that vast outer ring, most of everything we have ever photographed, sits in the strangest category reality offers. Side of the line where they can still be seen, wrong side of the line where they can still be touched. Their old light keeps arriving, their new light never will. They are, in every sense that connects to our future, already gone. And the word gone, which sounded like an exaggeration an hour ago, should be starting to sound like what it is. Plain accounting. If the phrase event horizon is tingling with familiarity, it should. It's the same phrase we use for the boundary of a black hole, and that is not a coincidence or a borrowing. It is the same physics, worn inside out. A black hole's event horizon is a surface no light inside can escape outward through. The cosmic event horizon is a surface no light outside can carry inward across. One is a trap you cannot leave, the other is a distance you cannot be reached from. And they even look alike. Watch something fall toward a black hole and you never see it cross. Its image slows, reddens, dims and freezes at the edge, a photograph fading on the wall of the universe. Watch a galaxy carried toward the cosmic horizon, and precisely the same thing happens. Its clock, as we receive it, runs ever slower. Its light stretches ever redder. Its image dims toward one final, frozen, infinitely stretched frame. Galaxies don't blink out at the horizon. They fade out over billions of years like embers, like the last chord of something enormous, sustained past hearing. We built telescopes and discovered the universe was full of neighbors. We measured carefully, twice, and discovered the house we share is stretching, and that the stretching accelerates, and that it therefore has a horizon, and that the horizon is close. The neighbors are still visible through the window, waving light at us from long ago. The window is real. The door, for almost all of them, has already closed. So let's do what careful people do with hard truths. Let's count. The observable universe holds, by recent counts, somewhere between several 100 billion and 2 trillion galaxies. The number keeps being revised. Counting everything visible in all directions to the edge of light is not a small bookkeeping exercise, but the scale is settled. Hundreds of billions of galaxies at minimum, each an island of millions to trillions of stars. The volume from which a photon launched tonight can still reach us. The sphere inside the cosmic event horizon contains only a few percent of that. Work through the geometry and the number that comes out is stark. Roughly 94% of the galaxies we can observe are already beyond reach. Some published estimates run higher still, toward 97. Call it gently 19 out of every 20. For every 20 galaxies in that famous deep field photograph, 19 have already left our future. What remains reachable, the universe where cause can still meet effect, where a message sent can someday arrive, is a rounding error on what we survey each night. All our maps are 94% memorial. I want to be precise about what beyond reach means, because the mind keeps trying to soften it into very far away. And it is not that. It is a different category of fact. It means if somewhere in one of those 19 galaxies tonight, a civilization pointed its most powerful transmitter at the Milky Way and broadcast everything it knew, its mathematics, its music, its warnings, its goodbyes, that signal, flying at the fastest speed the universe permits for 100 billion years, for a trillion, forever, would only lose ground. The gap it needed to close would grow faster than the signal could close it, always. The message would remain in flight for eternity, perfectly preserved, perfectly undeliverable. It means, symmetrically, nothing we ever do can matter to them. No probe we launch, no signal we send, no achievement of any descendant of Earth in any future era can ever touch, inform, warn, or comfort 94% of the universe we can see. Whatever kinship we feel looking at those galaxies, and it's real, you feel it looking at the deep field, it is now permanently one-directional. The universe has divided almost all of itself from almost all of the rest of itself, and both sides get to keep the photographs. And it means the sky is layered with expiry dates that nothing displays. The light arriving tonight from a horizon-crossed galaxy is finite in supply. The photons that left before the crossing are still in transit, still arriving, a pipeline that will keep delivering for billions of years. But the pipeline is filling from a source that has already stopped, in our terms, being able to add to it. Every such galaxy has a last photon, already committed, somewhere on the road. Some night, far beyond the lifetime of the sun, admittedly, that last photon arrives, and the galaxy's forwarding address becomes nowhere, ever again. Meanwhile, the line itself advances. The horizon is not fixed. Acceleration moves it, relatively speaking, inward through the crowd. Every second, while you have been listening tonight, while you fall asleep, while you dream, more of the universe crosses over. By some estimates, around 20,000 stars slip beyond the horizon every second, 20,000 suns a second, each perhaps with worlds, each certainly with mornings and weather and light, passing, mid-shine, out of the reachable universe. Since you settled into bed tonight, millions of stars have left your future. None of them noticed, neither did you. That's not a failure of attention. There is, in the deepest sense, nothing to notice. The crossing is silent, invisible, and marked by no event at all, anywhere. It is the quietest thing that happens in the universe, and it is happening constantly, at a scale the mind refuses politely to hold. If you want the goodbye to have a face, give it this one. Among the most distant galaxies ever confirmed is one called GNZ11, a small, fierce young thing whose light left it when the universe was only about 400 million years old. That light traveled 13.4 billion years to reach the Hubble telescope. The galaxy itself, carried by the expansion the whole while, now sits some 32 billion light-years away, receding if you run the arithmetic at several times the speed of light. GNZ11 is not slipping toward the horizon. It is long, long over it, since before the sun was born. We know its structure, its youth, its chemistry, its ferocious rate of starbirth. There are careful published papers about a place that has been strictly unreachable for most of the age of the universe. It's one of the most studied objects in the sky, and our knowledge of it is purely archaeological. Whatever GNZ11 became, a great spiral, an elliptical, someone's home, is a fact the Milky Way will never contain. And the leaving is not only a story about the far fringe. It comes closer than feels fair. Our local group is bound, that promise holds. But the next structure out, the Great Virgo Cluster, 2,000 galaxies, a gravitational metropolis a mere 65 million light-years away, the anchor of our whole corner of the cosmos, is not bound to us. The expansion is carrying Virgo away too, gently now, faster later. The same is true of every cluster, every supercluster, every glittering wall of galaxies in every map ever drawn. None of it is attached. In the fullness of the acceleration, the entire visible architecture of the universe beyond our own small household, Virgo, Coma, the great attractor, the whole shining scaffold, takes its place in the long procession toward the horizon. The deep future doesn't just lose the exotic distances, it loses the suburbs. Now, because this is a lot to carry, and because you're allowed to be comforted as well as awed, 3 honest consolations before we come home. First, nothing is being destroyed. Every one of those galaxies is fine. The stars burn on, the planets keep their weather. If anyone lives there, their night skies is as full as it ever was, and their own horizon is carrying us away with the same silence. Gone tonight has never meant harmed. It means unreachable. The universe sorting itself into households that can no longer visit, everything precious, surviving intact in every one of them. Second, the light does not stop. For the rest of the sun's lifetime and far beyond, the sky will remain full of those 19 out of 20 galaxies, their old light faithfully arriving, their images gradually reddening and slowing on timescales so long that every human generation will inherit what looks like the same sky. The album doesn't close. It just stops accepting new pages, one galaxy at a time from the outside in. And third, the consolation that the next part of tonight belongs to. The horizon does not get everything. Gravity, humble local gravity, holds some things too tightly for any stretching to take. Not much by the universe's standards, but it includes, as it happens, everything you have ever been able to see with your own eyes on a dark night, and every star any descendant of ours could ever hope to visit. The universe is leaving, but it is not taking the neighborhood. Before we come home to the neighborhood, I want to take you on one journey outward, the kind you can only take at this hour, lying still with your eyes closed. We've been talking about photons in the abstract all night. Let's ride one, and not just any one. Let's ride a photon that barely makes it, one launched from a galaxy sitting just inside the horizon on the last possible mile of the reachable universe. Its journey is the whole story of tonight lived from the inside. You leave the surface of a blue-white star in a galaxy 16 billion light-years from Earth. I'll keep calling it 16 billion light-years, though by the time this is over that number will have changed enormously. And that's rather the point. You are a single quantum of light, born in the skin of a star, and at the moment of your birth you are moving at the only speed you will ever know, the fastest one there is. For the first stage of your journey, everything goes beautifully. You cross your home galaxy in 100,000 years, nothing by tonight's standards. You slip past its last straggling stars through the thin, warm halo of its gas, and out into the true intergalactic dark, the emptiest emptiness there is, where you might travel 1,000,000 years between encounters with a single atom. Earthward, always. The galaxies of your home cluster fall behind. Ahead, the whole journey stretches out, and here is the first strange mercy of being a photon. For you, there is no time. At the speed of light, the universe's clocks stand still. You do not experience the billions of years. You experience departure and, if geometry permits, arrival. Everything in between belongs to everyone else. But we, watching from outside, see what the road does to you. The road grows. Every stretch of space you cross adds a little length behind you and, more importantly, ahead of you. In your first billion years, you close an enormous distance, but the distance remaining has not shrunk by that much because it was stretching while you flew. You are gaining, but the universe is dealing new road faster than the old road retires. And you are paying a toll the whole way. The stretching pulls at you personally. Your wavelength, the very size of what you are, lengthens, kilometer by kilometer, eon by eon. You left the star as fierce ultraviolet. A few billion years in, you are visible light, blue, then gold, then red, cooling like a memory. The stretch continues. You slide into the infrared, invisible now to any eye, a long, slow ripple of warmth gliding through the dark. Halfway through your journey, something happens far ahead that you will never see. The star you are aiming for, a yellow sun that had not even formed when you departed, ignites, gathers planets, and on the third one, oceans condense. You know none of this. You are a wavelength in the dark, faithfully getting longer, and the treadmill under you accelerates. This is the era, roughly 5 or 6 billion years ago, when dark energy takes the upper hand over gravity, and the universe's expansion stops coasting and starts to build. Behind you, your home galaxy's recession quickens. Somewhere back there, silently, with no ceremony whatsoever, it crosses the horizon. The gap between it and Earth begins growing faster than light can ever again close. You don't feel it. Nothing feels it. But at that moment, you become something singular. You are now the last male from a town that has left the map. Every photon that departed after you on your same errand will fly forever and never arrive. You made it out before the door swung shut, barely, and you carry, in your stretched and reddened wavelength, the final legible news from an entire island of 100 billion suns. The last stretch takes the longest, as last stretches do. The remaining road, though shorter, still swells beneath you. You close it meter by hard-won meter across the final billions of years. Then, one night, tonight, let's say, the journey ends the way every photon's journey ends. Instantly, from your point of view, departure and arrival press together with no time between. You fall out of the dark, 16 billion odd years old and stretched a dozenfold, into the wide silvered mirror of a telescope on a mountain on a small blue world. And you strike a detector, and you become, after all of that, one pale pixel, a single faint dot in the reddest corner of a long exposure image logged automatically, time-stamped, filed, one dot. And an astronomer, months later, reviewing survey data at 2 in the morning with cold coffee, pauses on it for 4 seconds, because something about the redshift makes her sit up slightly. Then she bookmarks it and goes to bed. That is what the arrival of the last light from a vanished galaxy looks like on our end. Not a trumpet, a pixel, a bookmark, and someone deciding it can wait until morning. It can. That's the strange grace of all this. The most final events in the universe are also its gentlest. No collision, no flash, no sound. Just the mail slowing and reddening, and one day, without anyone able to name the date, stopping. You are lying right now at the bottom of an ocean of such arrivals. Ancient light is landing on your roof tonight, on the shingles on the garden, on the thin curtain over your window. Light that outlived its own sender's reachability, finishing journeys that began before the Earth existed. The night sky is not a scene, it is a delivery, still in progress, of everything the universe managed to send before the doors began to close. And the oldest delivery of all, of the deepest, faintest, most stretched light there is, isn't in the sky at one point or another. It's everywhere. It fills the room you're sleeping in, and its story is next, because nothing in the universe says everything goes gently more perfectly than the first light ever released. In 1964, two radio astronomers in New Jersey had a pigeon problem. Arno Penzias and Robert Wilson were trying to calibrate a large horn-shaped antenna at Bell Labs, a leftover from satellite communication work for careful radio astronomy. But they couldn't zero it out. Wherever they pointed it, day or night, in every season, a faint microwave hiss remained, a static identical in all directions, coming, apparently, from the sky itself. They checked the wiring. They ruled out New York City. They evicted a pair of pigeons roosting in the horn and scrubbed out what Penzias, in the most patrician phrasing available, called a white dielectric material, pigeon droppings, in case that was somehow glowing in the microwave. The hiss stayed. It was coming from everywhere, and it would not go away. 40 miles down the road at Princeton, a group of physicists heard about the stubborn hiss and understood immediately, with a sinking professional envy, what it was, because they had been preparing to search for exactly it. If the universe began hot and dense and has been stretching ever since, then the first light ever released, the glow of the young universe itself, from the moment it cooled enough to turn transparent about 380,000 years after the beginning, should still be in flight. It never had anywhere else to go, but after 13-odd billion years of the road stretching beneath it, that brilliant orange-white glow should have been pulled 1,000-fold longer, out of visible light entirely, through the infrared, down into faint microwaves arriving from every direction at once, a hiss, identical in all directions. That would not go away. Penzias and Wilson had found the cosmic microwave background, the baby picture of the universe, the light of the beginning itself, stretched by the expansion into a whisper. It earned them the Nobel Prize, and it settled the great argument. The universe truly had a hot, dense birth. And the reason I bring it into tonight's story is what it tells us about where everything is headed. Because think about what you're actually being told. The brightest thing that has ever existed, the glow of the entire universe, everywhere, at once, is now a signal so faint you need a special antenna to notice it, and its wavelength grows longer with every passing eon. It is the premise of tonight, running on the grandest possible scale. Nothing destroyed it. Nothing ever laid a hand on it. The road simply stretched and stretches still, and the first light is fading out of the universe, not by dying, but by lengthening, the same fate in slow motion as every galaxy sliding toward the horizon. Here's the detail I find almost unbearably gentle. That first light is not rare. It's the most common light there is, around 400 of those ancient photons in every cubic centimeter of space everywhere, including the space in your bedroom. They pass through your window all night. A few of the oldest things in existence, light older than every star from before there were stars, are ending their 13.8 billion year journeys against your curtains, your ceiling, the back of your sleeping hand, every second of your life. If you're old enough to remember analog television, you've seen it. 1% or so of the snow between channels was the cosmic microwave background, the beginning of the universe dusting your living room. And it is, on the longest schedule imaginable, leaving. Every year it stretches a little further, thins a little more, whispers a little quieter. In the deep future, and now we are peering ahead trillions of years, its wavelength will stretch to the size of solar systems, then larger than galaxies, a light too vast and too faint for any conceivable instrument to catch. The universe's own birth announcement, still technically in the mail, but written in letters too large and too pale for anyone to ever read again. Keep that image, because when the last astronomers arrive, and they're coming in the final chapters of tonight, the fading of that whisper is one of the doors that will close behind them, and they will never know it was there. Before we come home, pause on how astonishing it is that we can put numbers on any of this, that a species on one small world can claim to know the recipe of everything, because the cosmic microwave background turned out to be far more than a birth announcement, mapped in exquisite detail by a succession of satellites, COBE in the 90s, then WMAP, then the European Planck mission. That ancient light carries a faint mottling, temperature ripples of a few parts in 100,000, the seeds of all future galaxies frozen into the first light. The precise pattern of those ripples, their sizes, their strengths, the way they echo against each other, functions as a kind of tuning fork struck at the beginning of time. And the tone it rings at depends on what the universe is made of. Analyze it carefully, cross-check it against the great galaxy maps and the supernova distances, and the universe's full ledger falls out to percent-level precision. Here is that ledger, the complete inventory of reality as measured. Ordinary matter, every atom, every star, every planet, every ocean and body and book, everything you have ever seen or touched or been, comes to about 5%. Dark matter, the invisible gravitational scaffolding that holds galaxies together, detected only by its pull, about 27%. And dark energy, the push, the stretch, the author of tonight's entire story, about 68%. Sit with the humility of that for a moment, because it may be the single most remarkable sentence modern science can utter. Everything humanity has ever called everything is 1/20th of what exists. The rest is two kinds of darkness, one that gathers and one that scatters. And the largest ingredient of reality, the majority owner of the universe, is precisely the one carrying the galaxies away tonight. The goodbye isn't a flaw in the universe's composition. It is the universe's composition. We live 5% creatures in the thin, bright residue of a cosmos that consists mostly of leaving. And yet, the good news is real, it's substantial, and it's ours. Time to come home and count what the horizon can never take. All night, we've spoken as if the stretching of space were irresistible, and across the great gulfs it is. But the expansion of the universe has a rival, and the rival wins every contest it's close enough to enter. Gravity. Here's the fact that saves the neighborhood. Space only stretches where nothing holds it. The expansion is not a force that pries things apart. It's what space-time does when it's left alone. Where matter has gathered, where gravity has knit a structure together, the knitting simply wins, completely, locally, forever. The space inside your body is not expanding. The Earth is not expanding away from the Sun. The Sun is not drifting from its neighbors on account of the stretch. The Milky Way is not being inflated like a balloon. Within any gravitationally bound structure, expansion contributes precisely nothing. The raisins in the bread, remember, don't grow, only the dough between them, and our raisin is generous. The Milky Way, a few 100 billion stars, is bound. So is Andromeda, our great neighbor, along with the Triangulum Galaxy and dozens of dwarf galaxies, all knotted into a single gravitational household astronomers call the local group, roughly 10 million light-years of territory, containing on the order of 1 trillion stars, tied together firmly enough that no acceleration of the cosmic expansion, not this one, at least, can ever pull it apart. Everything inside the local group is exempt from tonight. Every star you have ever seen with your naked eye, every constellation, every planet, the whole visible architecture of your night sky lives deep inside that exemption. The sky above your house, the one your eyes can actually see, is not leaving. It is the permanent collection. In fact, the nearest big thing in our sky is doing the opposite of leaving. Andromeda, 2.5 million light-years away, visible on dark autumn nights as a faint, elongated smudge, the most distant thing human eyes can see unaided, is approaching. Gravity has been reeling the two great spirals of the local group toward each other for billions of years, and in roughly 4.5 to 5 billion years, they will meet. We've told that story on this channel before, so tonight, just the outline and the reassurance. When galaxies merge, the stars themselves almost never collide. The gaps between them are too vast. The two spirals will pass through and around each other in immense, slow arcs, fling off streamers of stars, light up with new starbirth, and settle over 1 billion years or two into a single enormous elliptical galaxy. Astronomers, unable to resist, have already named it Milkomeda. Milkomeda matters to tonight because of what it will be, the final form of home. One great galaxy, 1 trillion suns, old and gold and calm, containing everything gravity managed to save from the expansion. Every star that was ever ours Every star that was ever Andromeda's gathered into a single household, drifting through a universe that is, by then, well along in the business of emptying. And that household has a long, long lease. The universe's stars are not near their end. Our sun has 5 billion good years left, and the sun is a sprinter by stellar standards. The small patient stars, the red dwarfs which make up the majority of all stars, burn their fuel so frugally that they will shine for hundreds of billions, even trillions of years. A red dwarf igniting tonight will still be quietly burning when the universe is 100 times its current age, when the horizon has long since finished its work and the last astronomers have come and gone. And Milkomeda will hold enormous reserves of gas from which new stars will keep kindling long after the sun is a memory. Put plainly, the neighborhood's lights stay on for at least 1 trillion years. Tonight's melancholy is about the far universe. The near universe, the one actually overhead when you step outside, is durable almost beyond meaning. Let me say clearly what permanent means for the sky you personally know, because it's gentler than you might fear and stranger than you might expect. The individual constellations are not permanent, but that has nothing to do with tonight's horizon. The stars of the Big Dipper and Orion drift on their own slow orbits through the galaxy, and over 100,000 years the familiar patterns will shear into new shapes, as they always have. The sky Homo erectus saw was already differently arranged. What is permanent is the cast, those stars, and everything else your naked eye can reach, all of it. Local group, nearly all of it our own galaxy, stays in the family forever. The shapes rearrange, the players remain. Human skies will always be full. They will simply, in the deepest time, all be portraits of home. So here is the honest shape of the future. From home, an island of 1 trillion suns, secure and shining, whose residents can visit, in principle, anything within their own vast galaxy, and, in time, nothing else at all. Beyond the island shores, the emptying proceeds on schedule. The other galaxies recede, redden, and slip across the horizon from the farthest inward. The reachable universe contracts toward the bound one until the two become the same thing. Everything you can touch is the island, everything else is photographs, and then, eventually, not even photographs. Which brings us, gently, because this is the part of tonight I've been both saving and bracing for, to the astronomers of that far future. The ones who will be born on the island after the last ships of light have come in. Because in 2007, 2 physicists sat down and asked, seriously and carefully, a question that sounds like a fable. When all the evidence has left, what will the universe tell its children about itself? The answer is the strangest, saddest, most quietly beautiful result I know in all of cosmology. The physicists were Lawrence Krauss and Robert Scherer, and their paper carried a title that gives away the ending: The Return of a Static Universe and the End of Cosmology. What they did was simple to describe. They took our best-tested model of the cosmos, the same accelerating universe every measurement tonight has rested on, and ran it forward not by millions or billions of years, but by 100 billion. Then they asked, suppose intelligent beings live in Milkomeda then? Suppose they build telescopes, do careful science, reason honestly from the evidence available. What do they conclude about the universe they live in? Walk through their sky, 100 billion years from now, roughly 7 times the current age of the universe, every galaxy beyond the local group has long since crossed the event horizon. Their last light has arrived, faded, redshifted beyond every conceivable instrument, and ended. The sky beyond Milkomeda is not merely dark, it is empty, in every direction, at every wavelength, without exception. The deep field of that era is a long exposure of perfect black. The cosmic microwave background, the hiss that told Penzias and Wilson about the hot beginning, has stretched by then to wavelengths larger than galaxies, its whisper diluted below any physical possibility of detection. The first light still fills the universe technically. No one will ever read it again. Even the chemical evidence blurs. The primordial gas, whose precise mix of hydrogen and helium is one of our clearest fingerprints of the Big Bang, will have been cycled through generations of stars, cooked and enriched and reshuffled until the original recipe can no longer be cleanly read from the sky. And the expansion itself, the great fact at the bottom of everything tonight, becomes unmeasurable. Expansion only shows itself between gravitationally bound structures. But from inside Milkomeda, there is nothing visible beyond the bound structure to measure against. No galaxies to catch receding, no redshift distance law to plot, because there is nothing at distance to plot. Hubble's discovery, the running universe, requires other runners in view. Theirs will be a sky without traffic. So take it all together. And here is what the honest astronomers of Milkomeda observe. One enormous, ancient galaxy, theirs, floating in an infinite, static, featureless black. No other galaxies, no background glow, no expansion, no evidence of a beginning. And here is the conclusion Krauss and Scherer drew, the one that has quietly haunted cosmologists ever since. Those astronomers doing everything right, observing carefully, hypothesizing conservatively, refusing to invent what the data doesn't demand, will conclude that the universe consists of their one island of stars, static and eternal, surrounded by void. They will be wrong about essentially everything. The expansion, the other galaxies, the trillions of other galaxies, the hot beginning, the stretching light, dark energy, the whole vast biography of the cosmos, all of it will be simply, permanently invisible to them. And they will hold their wrong picture not through stupidity or dogma, but through good science, faithfully practiced on a sky from which the truth has been withdrawn. The evidence will not be hidden. It will be gone, carried over the horizon eons before their sun ever formed. Some of them, perhaps, will speculate wildly about a bigger, older, stranger universe. And by every standard of evidence available to them, the wild speculators will be the unreasonable ones. Interestingly, we've been the Milcomedans before, and we even staged the argument. Remember the great debate of 1920, Shapley insisting the Milky Way was the entire universe, one island of stars in an endless void? That picture collapsed only because the evidence to overturn it was still deliverable. Andromeda's Cepheids were right there, waiting for Hubble's telescope. Shapley was wrong, but he was correctably wrong. The universe still had his correction in stock, on a shelf light could reach. The last astronomers will hold Shapley's exact picture, one island, endless void, and for them the shelf will be empty. The history of astronomy has been one long lesson that the universe is bigger than assumed. It is strange beyond words to realize that lesson has an expiration date. To be thorough, because the Milcomedans deserve every chance we can imagine for them, physicists have hunted for loopholes, faint fossils that might survive in that far future for a sufficiently clever civilization to read. There are a few candidates. Occasionally our galaxy flings a star out entirely, a hypervelocity star slingshotted by a close encounter with the central black hole. And such runaways, coasting alone into the void, would feel the cosmic expansion once they left the household. A heroic future astronomer who tracked one long enough might notice something odd in its drift. The abundances of the lightest elements, though scrambled, might retain a whisper of the primordial recipe for the most forensic, imaginable chemist. These are real proposals, published and argued over. But notice what they have in common. They are the kind of evidence you only pursue if you already suspect the answer. A hint is only a clue to someone who knows there's a mystery. The honest Milcomedan consensus, the textbooks, the careful reviews, still reads one eternal island and silence. The loopholes are not doors, they are keyholes in a room where no one knows there's anything behind the wall. Now, turn the telescope around, because this is where the story stops being about them. We laugh gently at the last astronomers, sealed in their island, confidently mismeasuring everything. But the horizon did not start moving today. It has been sweeping across the universe for 5 billion years, since dark energy took the wheel, which means the mail stopped arriving from some regions of reality long before we ever built an instrument to check. Krauss and Scherer said it plainly. We may already be the last astronomers of some earlier, richer universe. There may be entire chapters of the cosmic story, structures, epochs, whole categories of existence whose evidence crossed our horizon before the first telescope, before the first eye, leaving no trace in any sky we can survey. Our own careful, honest, well-tested picture of the cosmos may be exactly as complete as the Milcomedans, a perfect description of everything still visible from here. What have we already lost? It is not a rhetorical question. It is simply an unanswerable one, the cleanest example the universe offers of a truth with the receipts destroyed. And that, finally, is why the astronomers of our own era behave the way they do. Why the great observatories run all night every night, cataloguing billions of galaxies, why every deep field is archived, calibrated, copied, and stored with a care that borders on reverence. Whether they'd put it this way or not, they are doing the work of a household that has understood the situation. The evidence is leaving, the window is open now, and everything measured tonight is something the future can never measure again. We are doing more than studying the universe. We are taking its deposition, writing down the testimony of witnesses scheduled to disappear. And there is one more turn of this screw, quieter than the others, that I'll leave you to fall asleep on. Suppose our descendants persist, in any form, under any sun, into those far eras. They will not need to rediscover the Big Bang from an empty sky, because they'll have inherited something the Milcomedans born fresh will not. The records, our records. The deep fields, the microwave maps, the great galaxy surveys, the deposition handed down. But think about what that means knowledge becomes once the sky can no longer confirm it. A young astronomer of that era told about the expansion of the universe cannot check it. Told about 2 trillion galaxies, she can point her finest telescope at perfect blackness and find nothing. The expansion, the horizon, the crowded ancient sky, all of it will rest entirely on the testimony of the ancients, unverifiable in principle, forever. Cosmology, the most evidence-rich science we have, will become an act of trust in very old books. The Big Bang will still be true. It will simply no longer be provable. The difference between science and scripture, imposed not by any failure of reason, but by the sky itself withdrawing from the conversation. Every fact we archive tonight is a future article of faith. Every civilization gets the sky it gets. Ours, by pure timing, got the one with the answers still in it. Everything tonight has rested on one assumption, and honesty requires we look at it before we close. We've treated dark energy as constant, the same push per cubic meter of space, forever. That's the simplest reading of the data, the one Einstein's mathematics accommodates most naturally, and the future it writes is the one we've toured. The slow emptying, the island, the last astronomers. Astronomers call it the cosmological constant, and constancy is right there in the name. But nobody knows what dark energy is. And if you don't know what something is, you don't get to promise it will never change. Physicists have mapped the alternatives, and they bracket our gentle future with 2 very different ones. If dark energy were to strengthen over time, a scenario with the honest name of phantom energy, the horizon wouldn't hold politely out at 16 billion light years. It would creep inward, taking more with it, until in the final eras it swept through the exemptions we counted on, clusters torn from clusters, then galaxies unbound, then solar systems, then, in the last fraction of a second, planets, bodies, atoms, the fabric of everything shredded by expansion itself. They call that ending the Big Rip, and it deserves one calm sentence of comfort. The data does not favor it. Every measurement we have sits consistent with dark energy at or near constant strength. and even the pessimistic readings put any such ending tens of billions of years away at minimum. It's a monster from the mathematics, worth knowing about mostly because it makes tonight's actual forecast, the patient one, the one that leaves the neighborhood intact, look like the mercy it is. And then, just in the last couple of years, the other direction opened up. And this is a story still being written as you fall asleep tonight. A new instrument in Arizona called DESI, the Dark Energy Spectroscopic Instrument, a robot of 5,000 optical fibers that measures thousands of galaxies every clear night, has been building the largest three-dimensional map of the universe ever made. Tens of millions of galaxies arranged across 11 billion years of cosmic history, precisely to watch how the expansion has behaved over time. DESI's method is a beautiful inheritance from the early universe. Those same primordial ripples frozen into the microwave background also left an imprint on how galaxies gathered. A preferred separation, a characteristic distance baked into the arrangement of galaxies, like the regular spacing of ripples on a pond. A cosmic ruler, the same length everywhere at every era. Measure how large that ruler appears at different depths in the galaxy map, and you can read off exactly how much the universe had stretched at every epoch, a growth chart of the cosmos, era by era, drawn with a ruler the Big Bang itself provided. And beginning in 2024, that growth chart has carried a persistent, tantalizing hint. Dark energy may be weakening, not gone, not reversing, but perhaps very slightly less pushy than it was a few billion years ago, as if the universe's foot were easing almost imperceptibly off the accelerator. Let me be careful, the way the scientists themselves are careful. It is a hint, not a discovery. The signal sits at the uncomfortable strength where it's too large to ignore and too small to trust. It may firm up into one of the great discoveries of the century, or dissolve into better data. And the surveys running right now are designed to settle it. But it's worth lying in the dark for a moment with what it would mean if it's real. If dark energy fades, the acceleration fades with it. The treadmill slows. The event horizon, the whole iron geometry of tonight, loosens, recedes, perhaps dissolves entirely. Galaxies we had written off as unreachable would, over eons, drift back within the reach of light. The mail routes would reopen. In the most extreme versions, the universe's long goodbye would turn out to have been not a goodbye at all, but a long, cold pause. I don't want to oversell a 2 sigma and change anomaly at 1 in the morning. The overwhelmingly likely future is still the one we toured tonight. But there is something fitting, something almost narratively polite, in the fact that the universe, at the exact moment we finished writing its farewell, cleared its throat and said, perhaps. The story of the horizon was assembled by 4 generations of astronomers, each of whom found the universe stranger than the last generation could believe. It would be very like the universe to have one more revision in it, Either way, one thing tonight does not depend on any of it. Whatever dark energy does next, hold, strengthen, fade, the light already lost is lost. The regions that crossed the horizon in the eras behind us mailed their last letters long ago. And the sky above your house tonight remains exactly what we said it was, the fullest it will ever be. From here on, under every version of the future we know how to write, which is where the story was always going to end, not out at the horizon, up on your roof, somewhere above you right now, above the ceiling, above the weather. The whole cast of tonight is present at once. The bound and permanent stars of home going nowhere for 1 trillion years. The old light of 19 in 20 galaxies faithfully arriving from senders already over the line. 400 photons of the universe's first light in every cubic centimeter whispering against the window glass. And threaded invisibly through all of it, the line itself sweeping silently outward through the crowd. 20,000 suns a second, closing doors no one hears close. Every generation of humans has looked up and assumed the sky was the permanent thing, the fixed backdrop against which our brief lives flicker. Tonight, you know it's closer to the opposite. The sky is the most temporary exhibition there is, a gallery in the process of shipping out its collection, one gallery wing going dark per cosmic era, on a schedule written into the vacuum itself. The permanent thing, oddly, is the neighborhood, the few thousand stars your eyes can actually see, gravity's stubborn keepsakes, which will outlast every distant splendor in tonight's story. There's a habit of mind this can give you if you let it settle in, and it's a good habit for the small hours when your own worries loom large. Astronomers of the far future would trade anything to see what hangs over your house tonight. Not metaphorically, literally. The evidence above your roof answers questions their finest instruments will be structurally unable to ask. The most ordinary suburban night sky of your era, washed out by streetlights, half hidden by cloud, is a treasure beyond the reach of 1 trillion-year civilization born too late. You live in the universe's brief season of full disclosure. It is telling you everything, nightly, for free, for a little while longer, where it came from, how it grew, what it's made of, where it's going. All you ever had to do was be born in time, and you were. So no, the universe is not falling apart tonight. It is doing something much slower and much stranger. It is becoming private, sorting itself into islands, each of which keeps its stars, its warmth, its own long history, and loses gently, gradually, only the view. What's ending isn't the universe. It's the era when the universe could be known. And you're inside that era now, near what may be its high noon, lying under the fullest sky anyone will ever see again. And if tonight leaves you wanting one small, real thing to do with all of this, not tonight, but some clear, moonless evening in autumn, here it is. Find the constellation Cassiopeia, the bright zigzag W, and let it point you a little southward to a patch of sky that looks empty. Look slightly away from it. The corner of your eye sees faint things better, and be patient. What will slowly surface is a small, pale, elongated smudge, easy to mistake for a wisp of cloud, the Andromeda Galaxy. 1 trillion stars, 2.5 million light-years away. The most distant thing a human eye can see without help, the photons finishing their 2.5 million year journeys against your retina, there in your garden. And here is why it belongs at the end of tonight. Of all the thousands of galaxies in all the deep fields, that faint smudge is the one great galaxy that is not leaving. Its family. It's the one coming home. Every other galaxy in tonight's story requires instruments to see and is bound for the horizon. The single one your own eyes can catch is the single one gravity chose to keep. The universe, whatever else it's doing, arranged for the only other galaxy you can personally witness to be the one that stays. That seems like something worth sleeping well beneath. Now, as we come to the end of tonight's long goodbye, let's gather it in, all of it, and set it down gently where it belongs. We started with a photograph, 3,000 galaxies in a keyhole of dark, and the quiet truth that it was an album, not a window. We watched Slipher find the fleeing spirals, Levitt find the measuring tape, and Hubble find the running universe. We stood with two rival teams in 1998 as the running became accelerating, and the accelerating drew a line across the sky. We rode a photon 16 billion years to become one pale pixel and a bookmark. We heard the universe's first light hissing in a New Jersey antenna between the pigeons. We counted what leaves 19 galaxies in 20,000 suns a second, and we counted what stays 1 trillion suns bound and shining home. And we met the last astronomers, honest and wrong under an empty sky, who taught us the real lesson of tonight, that the great privilege of our era is not where we live, but when. Think of what that means about us, this small species on its bound little world. The universe never announced any of this. The goodbye is silent, the line is invisible. The sky lies beautifully every single night. And yet, a few generations of people in the flicker of a single century noticed. They caught the universe leaving from the stretch of old light, from the faintness of dying stars, from a hiss that would not go away. They noticed the spirals were fleeing, and they followed the evidence. They noticed the candles were too faint, and they believed their own measurements over their own expectations. They noticed the hiss was the beginning of everything, once the pigeons were excused. And when they understood that the evidence itself was leaving, they did not despair. They built bigger archives and pointed everything they had at the dark and started writing it all down, the deposition of the witnesses taken just in time. That is what we are, at our best. The universe's court reporters working the night shift of the only era with the case still open. Thank you for spending this night with the leaving universe, from a grain of sand keyhole full of galaxies to the island of 1 trillion suns that no horizon can ever take from us. If tonight's journey moved you or made the dark above your roof feel less like emptiness and more like the most generous view anyone will ever have, take a moment, whenever you surface, to like the video and subscribe. It genuinely helps this quiet corner of space keep going. And now, let all the numbers go. The horizon will still be doing its slow work tomorrow and the day after, and it needs no help from you. Somewhere above your roof right now, light 13 billion years old is ending its journey on the shingles. The last mail from towns that left the map before the Earth was born, still arriving, still faithful, still soft. It fell on this world before there were eyes. It fell on the dinosaurs. It fell on every human who ever slept. Tonight, it falls on you. And of every creature it has ever landed on, you are among the very few who know what it is. The fullest sky anyone will ever see again is over your house tonight. Sleep well beneath it.